Welcome back to lesson 5. Now that we understand what significant figures or significant digits are in measuring instruments, let's learn how to count them. Precise measurements are dependent on the tools used to take the measurements. If I measure time with a digital alarm clock, I will only be able to measure up to the minute, right? 10:58 or 10:59, for example. If I use the timer on my cell phone, I can measure seconds as well. Olympic stopwatches measure to the 1/100th of a second. Each of these instruments, the digital clock, the alarm clock, the timer, and the stopwatch, each one of them measures time, but each of them measures time to increasingly more precision. That should be precision. Significant figures refer to the number of digits in a measurement. It is crucial to report a measurement up to the precision of the instrument, not more and not less. So here is a method for determining the significant figures in a measurement. Here's a sample problem, and we'll walk through this. How many significant figures are in, I can't even read this number, 100,460.0 centimeters? Here's a method for determining the significant figures in a measurement. Number 1, if the measurement contains a decimal, you start with the leftmost non-zero number and count all the digits from there to the end of the number. All of these digits are significant. So here we have a sample problem. How many significant digits are in 100,460.0 centimeters? Since the number has a decimal, I'm going to start counting my digits from the leftmost non-zero number, which is the 1, right? That's why I numbered it here. And I'm going to count all the numbers to the right. 1, 2, 3, 4, 5, 6, 7. This measurement has 7 significant figures or 7 significant digits, or what I call 7 sig figs. Notice that there are 2 types of zeros in this number. This will be important later on. Zeros number 2 and 3 are called trapped zeros because they're trapped between, let me redraw that, because they're trapped between 2 non-zero numbers. And numbers 6 and 7 are called trailing zeros. We'll get to that in a little bit. Just keep that in the back of your mind. Here's another sample. How many significant figures are in 0.0005 milliliters? This has a decimal. So again, according to this rule, we're going to start at the leftmost non-zero number, which is this, and we're going to count all the digits to the right. There are no other digits to the right, so it's just one significant digit, one sig fig. And we can even do this with scientific notation. Notice that in scientific notation, the exponent does not play a role in sig figs. The exponent just tells you about placeholders. It's not about measurement, okay? So we're just going to look at the significant. It has a decimal. So we are going to measure from the first non-zero digit, which is the 2, all the way to the right. 1, 2, 3, 4. And when I say all the way to the right, I do not mean counting the exponential. Of course, the exponential is crucial in understanding the value of this number, but not in determining sig figs. So this number has 4 sig figs. Second rule in counting sig figs. If the measurement does not contain a decimal, start with the rightmost non-zero number and count to the left. Count right to left. So here we have 2,500 feet. Yes, there's an implied decimal, but we're not talking about implied decimals. We're talking about explicit decimals. So there's no decimal here. So we're going to start with they say the rightmost non-zero digit, which is 5, and we're going to count to the left. So we have 2 sig figs in this number. Here again, we have more trailing zeros. However, in the absence of a decimal, I don't think I like the way I wrote this. In the absence of an explicit decimal, oh, I'm sorry. Yeah, that's right. In the absence of an explicit decimal, that's what I mean. Trailing zeros are not significant. Here, problem number 5. How many significant figures are in 902? No decimals. So we're going to start with the rightmost non-zero digit and count all the way to the left. 1, 2, 3. There are 3 significant figures in 902. usually I teach significant figures this way, and this is you're gonna help understanding the zeros when I talk about these rules. But I'm hoping that those few examples before it makes this a little bit easier. Sometimes students get caught up in sig figs, and it's really fairly simple. So here are the rules. All non-zero digits are always significant. So we have non-zero digits in here, 1, 4, and 6. So all 3 of these digits are significant. All trapped zeros are significant. So we have 2 trapped zeros here. These guys aren't trapped because they're trailing zeros. So we've got 2 trapped zeros, and all trapped zeros are significant. Okay. So far in this number, we've got 3 sig figs plus 2. Number 3, trailing zeros are significant if there's an explicit decimal. Is there an explicit decimal in this number? Yes, there is. So both trailing zeros are significant. So those count as well. Leading zeros are never, ever significant. This number doesn't have any, so I had to put in a different example to show you. Those are leading zeros. They are never significant. So the total number of significant figures in this measurement, 100,460.0 centimeters. Remember, non-zero numbers count, that's 3. Trap zeros count, that's 5. And trailing zeros with a decimal count, that makes 7. 7 significant digits. Here in practice problem 6, I want you to go through and count the number of significant figures in each of these measurements. Pause the video and do so, and come back only once you've finished. Welcome back. So let's count some significant figures. We've got some with decimals and some without. The first one has no decimals, so we're going to start at the rightmost non-zero digit and count this way. So this has 2 sig figs. The second one has a decimal, so we're going to start at the leftmost non-zero digit and count to the right. So that's 4. The next one also has a decimal, so we're going to start at the leftmost non-zero digit. Notice it has an exponential, but we don't count that in sig figs. So we go to the first digit and to the right. That's also 4 sig figs. In 130,100, there's no decimal, so we're going to start with the rightmost non-zero digit and count to the left. So that's 1, 2, 3, 4 digits. And this number, 0.00300, sure as heck does have a decimal in the number. So we're going to start at the first non-zero digit and count to the right. So this would be 3. Notice in this example that we have leading zeros, don't count. Leading zeros never count, but we have trailing zeros. So the 3 always counts, right? All non-zero digits count. And the trailing zeros count because somewhere in this number is an explicit decimal. We can't apply significant figures rules to all numbers because not all numbers are measurements. Significant figures only apply to measured numbers. Exact numbers, like counting numbers, such as how many students are in a classroom or how many pages are in a book, are infinitely significant. And you should never use them to determine the number of significant figures in which to write your answer. And numbers and definitions should also not be used to determine the number of sig figs. For example, 12 inches equals 1 foot is a definition. It's not a measurement, and therefore it too is infinitely significant. Okay, so this brings us to the end of this lesson. There is a worksheet on significant figures to give yourself more practice, but also combined with that is a worksheet on calculations involving sig figs. So you may want to go on to the next lesson before you tackle that worksheet. See you in the next lesson.